The concept of this video is writing polynomial functions when given a zero. So essentially, we're going to be working backwards. We've been working for a while on finding these zeros. Now I'm going to give them to you, and you have to kind of work the opposite way. So essentially, the steps in which that we need to take this is that we're going to set each intercept, or actually I'm going to say zero here. Set each zero equal to x. And then your next step is to get x to equal 0. And then from there, we're going to multiply all, I'm going to say expressions together then. Those 3 steps. This is a pretty large section of work here. This takes a lot of work. So please, we're going to start slow and then kind of ramp our way up, okay? So I'm going to start with number 1. And the first thing I'm going to do is I'm going to set these all equal to x, right? Because these are x intercepts. So what I'm saying is that x equals 2, x equals -3, and x equals 0. Once you get to this x equals 0, what is on the other side of it is one of the things that we're going to multiply together. So that one is done. To get the other 2 to equal 0, for in this case, I would subtract the 2 over, so I get x minus 2 equal to 0. And on this, I'm going to add 3 and get x plus 3 equal to 0. So in this very simplistic case, I'm trying to find the binomials that those zeros came from. And then after you get those in this case, 3 of them, because there were 3 zeros, we would then multiply all of this together. So x minus 2, x plus 3, and x. I'm going to distribute this parenthesis to the one behind it. First, you could also box this. It doesn't really matter, but essentially we are left with x squared plus 3x minus 2x and minus 6. And when you combine, you get x squared plus x minus 6. That answer is just from the multiplication of these 2 things. I now am going to have to drop down the x value. So if I distribute the x to those 3 terms, I'm left with x cubed plus x squared minus 6x. This is my binomial, or I'm sorry, my polynomial, that produces those 3 zeros. And you could check this. I mean, you could graph the polynomial that we just got and make sure that it intersects at the x-axis at those 3 places. So again, set the x values, the intercepts, the zeros, set them equal to x, get that to expression, that equation to equal 0, and then multiply however many, 3 or 4 together to get your polynomial. So this was level 1. The numbers, the zeros were integers. Life is great. So let's keep with rational numbers, but introduce a fraction. So it doesn't change, the fraction doesn't change how things work, right? So I have a 0 of -2 and a 0 of -4/5. So x equals -2 and x equals -4/5. So I'm going to add the 2 over for this one and get x plus 2 equals 0. So there's my first thing that I'm going to have to multiply. For the fraction, I could add 4/5, but it doesn't really help me. So instead, I'm going to undo the fraction one step at a time. So I'm going to multiply by 5 on both sides. And then I'm going to add 4. Here's my second thing. But I also have to remember that there is a multiplicity of 2. So what that means is there are actually 2 of those x plus 2's. So now we can set off to multiply again. Remember, you can only multiply 2 things at a time. So if we multiply just the 2 x plus 2's, we would be left with x to the 4th plus 2x plus 2x plus 4. Which is, I'm sorry, that is definitely not x to the 4th. I apologize. X squared. So we're left with x squared plus 4x plus 4. And now if we drop down the second parenthesis, we have to multiply again. So I'm going to distribute the x squared, then the 4x, then the 4. And I do this kind of in tiers, so meaning I'm going to try to line up my like terms here. So this polynomial, we would argue would be 5x cubed plus 24x squared plus 36x plus 16. Before we can start the more complicated types of examples, so again, these are all up here, these are all rational zeros, this section, right? So before we can start the imaginary or the irrational, right, which is where we haven't gone yet, you need to remember that both of these things come from the quadratic formula. And when a lot of times you're presented a zero, you're not given the full set of zeros. That you have to use that idea of, you have to remind yourself this came from the quadratic formula. So when looking at this imaginary number, this is only one of the things that came from the quadratic formula. So if you remember back, this would have been 2 plus or minus I. So this given zero is only one of the zeros, okay? So you would have to list its conjugate partner. So its conjugate partner is 2 minus I. So that's just me going this way on that plus minus sign, okay? Or with this one, this would have been from 3 plus or minus I. So this conjugate partner would be 3 plus I, meaning we're going this way on the plus minus sign. The same thing exists for irrational numbers, right? This expression right here came from 3 plus or minus radical 5. Okay, well, I've only been given the top part, so I need the bottom part of this, which would be the conjugate partner of this is 3 minus radical 5. And last but not least, on this one, it would have come from negative 3 plus or minus 2 radical 2. I've been given the top part, so I need the bottom part down here. So this conjugate partner would be negative 3 minus 2 radical 2. You have to keep that in mind as we continue on, because that plays a part in this, that we need to make sure that we include both, okay, or the idea that both exist. I'm actually going to switch things around and do number 6 first. Now that I've taught this twice, I think that 6 makes sense to go first, and then we can do 5 after. So on number 6, we are being introduced to the idea of an irrational zero. So the first thing to remember is that this technically, there's a plus minus there, right? That we need both partners, both conjugate partners there. I'm sorry. So I'm going to set x equal to them the same way I have been. And then I'm going to get x to equal, to get it to equal 0. So multiply by 3, add 4. So here's my first one. However, when it's irrational or rational, I want to isolate the plus minus the radical. And we're going to take care of it then after that. You don't have to do it this way, but I believe that it really brings down the number of steps that we're going to have to do. So I'm going to subtract the 3 like I normally would. So x minus 3 equals plus minus radical 5. And then from there, I'm actually going to stop and not get it to equal 0. Okay? Because I can get rid of this entire thing, the plus minus and the radical, by squaring both sides right now. So that's what I'm going to do. I am going to square the left and square the right. Okay? When I square the left, I'm getting x minus 3 times x minus 3. And when I square the right, no matter if it's negative or it's positive, it's not going to matter because the negatives would have partnered up. And the positives, it doesn't matter if they partner up. So really, I'm just squaring radical 5. And the square and the radical would wipe out. so I'd be left with 5. So if I multiply this out, I would get x squared minus 3x plus 9 equals 5. And then x squared minus 6x plus 9 equals 5. And then I'd subtract the 5 over. So x squared minus 6x plus 4 equals 0. So now, it was a long process to get it to equal 0, but now I know what the two things are that I have to multiply. I have this, and I have this linear example here. So if I put those together, so 3x plus 4 times x squared minus 6x plus 4, if I distribute through, this will give me my third degree polynomial here. And I'm left with that right there. So again, when you have an irrational number, this is where you do not equal to 0, but isolate plus minus a radical, okay? And then square both sides. Okay, so now let's try what I think was the hardest question on the page. All right, so if we look at this one, this has 2 rational zeros and then an imaginary, which remember has a plus minus sign. So again, we would set them all equal to 0. And I'm gonna teach this the same way I taught that irrational. I'm gonna actually get x equal -2 plus or minus 2i. From there, we're gonna do the same thing with the first two that we have been doing. So this gives me the first two things that I would have to multiply to be successful here on my journey towards the polynomial. However, when we go over here to the imaginary numbers, just like with the radical, we are actually going to look to isolate the I term, okay, with the plus minus. So in that case, I'm just going to add 2. And we're going to do exactly what we did with the irrational. We're going to square both sides. So x plus 2 times x plus 2 equals 2 squared is 4 and I squared is I squared. So now we're left with x squared plus 2x plus 4 equals 4 times, if you remember back, I squared. Remember, I is equal to the square root of -1. And if we were to square I and square the square root of -1, we would get I squared equals -1. So this becomes 4 times -1. From there, when we combine like terms, x squared plus 4x plus 4 equals -4. And remember, our last step is to get this to equal 0, so we add 4 to both sides. That's a lot of 4s, I know. And we're left with this quadratic. So here is our last thing that we're going to have to multiply. Before I think that we should multiply the two linears together. So the next step that I took was to multiply 3x plus 5 times x minus 1. And when you do that, you're left with 3x squared plus 2x minus 5. So I am now left with multiplying these two quadratics. This is a lot of work because we've already multiplied twice and we're not done. We still have the largest set of multiplication to do. So last step here is we need to multiply these last two quadratics together. And there, we did it. We would be left with this fourth power polynomial. All right, so that was a lot. That was absolutely a lot. And there are 6 questions in the back that I'm not going to work through all of them, and I've put the answers up for a lot of them. I just wanted to just reiterate again on the next 2 questions in the back, kind of where to stop, okay? And that's it. And then I'll just kind of show you the answers that you can kind of work through and move in that regard. So number 7 on the back, remember that there would be a plus minus in front of that radical. Anytime you see a radical, you got to put a plus minus. Same thing with this imaginary. There's a plus minus. So in this case, it would be x equals plus or minus radical 5, and x equals -1 plus or minus 3i. Remember that in both of those cases, we are looking to isolate the plus minus the radical and the plus minus the I term. So in terms of the first one, I don't really have anything to do. And in the second one, I would have to add the 1. And at this point, in both of these, we would now look to square the sides. So this would be kind of your journey that you want to kind of embark on from here on if you were trying to finish this. At the end of this question, you should get x to the 4th, 2x cubed, 5x squared, minus 10x minus 50 on that one. On number 8, same kind of thing, right? When you get to this point, you're going to have x equals 3 plus or minus radical 10. Remember, you're looking to isolate this radical before you start, okay? So please, please go ahead and give these a good try if you'd like. And I know these are hard, so if you're feeling very unsuccessful or very overwhelmed by the steps, come and work with me if you need anything at all.